Okay, so here's a copy of our blank unit circle. If you'll notice, we've got a couple of different parts to the blank unit circle, and when we're talking about degrees and radians, the unit circle is going to become huge for us because it's how we communicate about different angles, and we use the easy ones that we know and just put them in a conveniently located chart here all in one place in this unit circle. Okay, so what we've got is this circle has 1 as its coordinates. Okay, so this is a circle with a radius of 1. On page 131 in your book, there's an excellent diagram that we're actually going to use to fill in part of this. What I would like for you to do is take your blank unit circle and fill in as much as you can. We're not going to be using these for today. Okay, we will eventually use those. These are the pieces that we're going to be using. This blank and then the degrees sign here. Okay, so on page 131 it looks something like this. They give us the fact that this right here is either 0 degrees or it's 360 degrees. Okay? Also, they give us the fact that this is either 0 or it's 2 pi all the way around, as we discussed yesterday. So as we move up along here, we're going to assume that we're starting from 0. So what we're going to do is this is going to be a 30-degree angle, and its radian representation is going to be pi over 6. If we converted 30 degrees to radians, we get pi over 6. So moving along here, we're going to go 45. This is going to be pi over 4. This is going to be 60. Pi over 3. Okay, and so our 90 degrees here is going to be as far as we're going to go for right now, because you, my friends, are going to fill in the rest. You can pause here, fill in the rest. Remember, page 131 is where you can get this information. Okay, so as we go around, we're going in increments of 30s, 45s. Now, if you'll notice, we kind of get this pattern here where we have these 2 skinny angles in each quadrant. That's because we're talking about reference angles. So this is 30 degrees here. Well, this is also 30 degrees here, but it has a different representation because it's in the second quadrant. Okay, so this is going to be something like, 150 or something like that. Okay, that's how we're going to do this. And so when we get into this next part, we're going to be using our unit circle to find the exact value of sine of pi over 6. We could put it into our calculator, but our calculator is not going to give us what we want. Here's how we're going to do this. If we look at our unit circle, we find that pi over 6 is equal to 30 degrees. And so really, we're going to say the sine of pi over 6 is equal to the sine of 30. Here's how we're going to tackle this. We're going to assume here that we've got our triangle. We've got a 30-degree angle. And this triangle is sitting in the coordinate plane thusly. Okay? And so it's going to be a 30, 60, 90. And so once again, we remember, this is going to be a 1 here. This is going to be a 2 here. This is going to be a square root of 3. And so when we find the sine of pi over 6, it's going to equal 1 over 2. Okay? And so that's what we're dealing with here. When we're talking about this, we're using the unit circle to find these exact values. All right? So moving right along, let's talk about 7 pi over 6. We have 4 times sine of 7 pi over 6. I just happen to have this drawn into my unit circle because I've done my little bit of homework here. And so when I go to 7 pi over 6, I find that that is here. Okay? 7 pi over 6 is going to be 210 degrees. And so this reference angle is going to be 30 here. And so when I go to do this, what really I'm saying is 7 pi over 6 is equal to 210, which means my theta hat, my reference angle, is going to be equal to 30 degrees. So let's draw in our coordinate plane. Draw in my 30, 60, 90. So I've got 1, I've got 2, I've got square root of 3. This is negative 1 here. Okay? So let's break this down. I've got 4 times the sine of 7 pi over 6, which is going to be equal to 4 times the sine of my reference angle, which is 30. Okay? So here's what I'm going to do. I'm going to have 4 times. Now, the sign here is going to give me negative 1 over 2. So this is going to be sine 7 pi over 6 is equal to negative 1 over 2. I'm going to put that in here. So I'm going to have that this is equal to negative 2. Okay, so that's my sign. So this is how this goes. We're substituting values to give us what we want using the unit circle. Okay, let's try this one. 4 sine of 2x plus pi when x is equal to pi over 6. So let's try this. 4 sine 2x plus pi, x equals pi over 6. I always like to rewrite my problem because then I'm going to substitute. So it's going to be 2 times pi over 6 plus pi is equal to 4 sine. Now, pi over 6 times 2. I've really got, that's going to be pi over 3 because I've got 2/6 then. Whoops. Plus pi. I need a common denominator, so I'm going to make my common denominator 3. So I'm going to have pi over 3 plus 3 pi over 3 because this is equal to pi, remember? Okay? So that's going to be 4 sine of 4 pi over 3. I wonder if that's in my unit circle. Let's look. Well, it's certainly not in mine, but if you've been doing your homework and you went back and put in your values, you're going to find that 4 pi over 3 is down here. And if you do a little bit of math, you're going to find out that that's 240 degrees. Okay, 240 degrees. So our reference angle is going to be 60. So when I go back here, I'll draw on my x and y axis. I'll put in my theta, and my reference angle is 60. So that means I've got a 30, 60, 90. So this is 30. So this means this is negative 1, still 2, negative square root of 3 here. So after I substitute, here's what I've got. 4 times the sine of 4 pi over 3, which is really sine of 60, which is equal to 4 times, I'm going to reduce here, 4 times, and the sine of 60 is going to be opposite over hypotenuse, negative square root of 3 over 2, which is going to give me, this is going to cancel, I'm going to have a 2 out here, 2 times negative square root of 3, which is equal to negative 2 square root 3. Okay, so you see kind of how this is rolling here. We are using our unit circle to make our lives easier. I noticed there are no decimals here. There are no decimals. We're not using decimals in this case. Okay, so you need to fill in your unit circle and be able to do these problems when you get back. All right, thanks for watching.